Right. Today we are going to discuss about the design procedure of combinational circuit. The logic circuit or digital system may be of sequential or combinational circuit. Here basically the logic circuit for digital system that has been classified into two types. One is a combinational circuit and another one is a sequential circuit. Whereas here in the combinational circuit, the output that produce depends upon the present input. Whereas in the sequential circuit, the output that depends upon the present input as well as the past output. Here in this combinational circuit, here it consists of the logical input variables, logic gates, and then the output variables. Where it will have the n input and then the m output. Depends upon the n input, the m output that will be produced. The n input will be the present input. Here, next we will be discussing about the design project for combinational circuit. First, for the designing of the combinational circuit, first we have to observe the given problem statement. Next, from the problem statement, we have to identify the number of input variables and required output variables. Then we have to assign the letters symbols to the input and output variables here based upon the problem statement. Next we have to form the draw the truth table, and then we have to derive the relationship between the input and then the output. That is the truth table that is define the required relationship between the input and then the output, where for the corresponding input what output the combinational circuit that should produce, that we have to derive. Next, from the truth table, the Boolean function that is simplified by using the K-map method, and then the output function that will be obtained. That is the simplified Boolean function of each output is obtained by using the K-map simplification method. Next, after simplifying the Boolean function, next we have to draw the logic diagram. Next, after drawing the logic diagram by using the basic gates, then we have to verify the correctness of the design. Here, how to verify the correctness of the design means the correctness of the design that will be verified based upon the problem statement. Okay, what are the input that will be giving, what is the output that will be getting. If for the corresponding input, if you are getting the output what the thing that has been stated in the problem or design, then the circuit is right. Or else we have to check once. If you are not getting the, if you are not attaining, or if you are not attaining the problem, find if you are not attaining the solution for the problem statement means again we have to check the truth table. Okay, whether we derive the for corresponding input, whether we derive the exact output or not, that we have to next. Next we have to, next we are going to design, uh, discuss about one design problem. Here we have to design a logic circuit. Okay, where it has the two input A and B. A and B are the two inputs, and then Y is the output. Okay. First, while you are designing a combination circuit, you please go through the statement clearly and then please understand the statement. Then only you can able to design the circuit properly. Here, design a logic circuit. Okay, over, which has A and B as the input. Here A and B is the input and Y is the output. That means the problem statement which is given here is that it has the two input A and B and Y, only one output Y. Next, the output goes low. Okay, here the output is going low. Here in digital circuit or logic digital circuit, you know that the state that will be represented in either it is high or low. If it is high means then it is 1. If it is low means then it will be represented as 0. The output goes low when any one of the input is high. That is, any one of the input is high means either A or B is high means the output that will goes low, or else the output will remain 0. Okay, next we have to draw the block diagram based upon the input and output. Here two inputs are there, A and B are the two input, Y is the output. Okay, next we will go to the truth table. Here there are only two inputs are there. A and B are the two inputs. So A and B two input and Y is the output. Here if A is 0, B is 0. What is the problem statement? If any one input goes high, then output will be low. Here if you see A and B are the two inputs. For the two input combination 2 power n, 2 power n. That means 2 power n means 2 power 2, 4 combinations will get for A and B. 0, 0, 0, 1, 1, 0, 1, 1. If here from the problem statement, if any one input that has to go high, then A is 0, B is 0, then obviously the output will be high. Here A is 0, B is 1. One input is high. So the output that has gone to 0. Here A is 1, B is 0. Then output will be 0. Here A is 1, B is also 1. Then the output is 0. Next, here we can use the two variable K map. Here we can use two variable K map. Here for the combination of A and B combination, A is 0, B is 0. What is the output? Output is 1. Next, A is 0, B is 1. What is the output here? 0. A is 1, B is 0. What is the output here? 0. A is 1, B is also 1. What is the output here? 0. Here we have to find the sum of maintain. Here for two variable K map simplification method, you know that first we have to check whether any possible combination of upo groups are there. We have to check no. Any possible combination of group of two cells is there? No. Only single cell is there. That is this cell alone is there. Then it will have the A bar, B bar. Then the output equation Y equal to A bar, B bar. Then we have to draw the logic circuit. That is A bar, B bar is the input. Here we can use the AND gate. The output equal to Y. Now you can check the combination of the inputs, whether you receive the exact output or not. Here A is 0. A is 0. A is 0 means A bar will become 1. B bar will become 1. Then output will be 1. Here A is 0. B is 1. That means A will become 1. B will become 0. Then the output will Y equal to A bar, B bar, that will be 0. Then A equal to 1, B equal to 0. That means A bar will be 0, B bar will be 1, then the output Y will be 0. A is 1, B is 0. That means A bar will be 0, B bar will be 0, the output will be 0. By this way, we can design the logic circuit. Thank you.